Okay, so my name's Frank, and the talk I have for you to start us tonight is called Client-Side Python with Piodide, which is a general Python distribution basically for the browser. So Piodide is a tool capable of running pretty much any program you can write in Python on your web browser, which makes it really useful for a variety of web development applications. Since I'm not a web developer, I'm going to focus on a kind of Python application like a demo or a math widget or an indie game. And I actually have an example to work with for this talk, so I'm going to spend a couple minutes showing you my demo, which is it's a little mathematical art application. And if you've ever seen a mathematical art anything, you've probably seen an image like this. This is the Mandelbrot set. I thought of looking for a really good, deep, beautiful render of this, but I just pulled this off the top of its Wikipedia page. There's like a million of these kinds of images on the internet made by different hobbyist programmers, and there's lots of different variants, K-Brots and Julia sets, and I'm sure people in this room have made something like that with their own code, right? So my own foray into iterative fractals was inspired by a friend of mine who thought it might be nice to have a little application where you can draw these and not just have this cardioid that we're all sick of, but have like a user on a canvas doodle anything they want. And so I'll show that first just running from my terminal. We pull up this window, and you can draw, and it gets a little Mandelbrot-like fractal boundary around it, which is cool, or at least I think it's cool. I'm biased because I wrote it, but why am I drawing a sad face is because, well, I'm drawing a sad face because using this is not very convenient to use. Like, if I want to share this with the world, or even with my friend whose idea it was, he has to clone my repository or install a package that I wrote and then run it from his terminal or an IDE or something. And that's maybe more trouble than most people are willing to go to make a little doodle like that. So if you have your own Python application that makes a cool visual or plays a game or something like this that you'd like to share with people freely, what would be really nice is if you could just send them a link that they could open online, and in their browser they could go and draw something like this, or you play your platformer game or anything like that. And I have that for the Fractalinator here. So any Doofenshmirtz fans in the audience might like the suffix. But let's draw. Oh, and it doesn't go poorly with the display. We can draw a nice happy face now because the ease of just navigating to a URL and seeing a public site is just puts a big smile on everybody's face. The nose doesn't really show up. So that's the kind of application that this talk is going to focus on. The talk is not about the Fractalinator, but now that you've seen it, I'm going to move on to Piodide, which is the tool that makes this easy to make a kind of program like this and put it into a little static website like I pulled up. And I'm going to start that off with some web development basics. If you've ever built a website or made any sort of application online, you can maybe tune out for the next couple of minutes because I'm just going to define the terms client-side versus server-side. Client-side code is what we were just looking at, controlling that drawing window. It's code that's running in your web browser on your computer, and it's written in JavaScript because that's what browsers can interpret, versus server-side code, which is running probably in a giant warehouse somewhere owned by whoever is running the website. And that can be in any language that developers choose. And historically, if you had wanted to make a Python application like mine visible online like this, you would probably need a server backend to serve it to a web browser and a little JavaScript wrapper for it. My favorite example, by the way, of client-side and server-side execution interacting with each other is if you've ever gone to googlemaps.com, and you might notice, especially if you have slow Wi-Fi, that when you pan around or pan and zoom on Google Maps, your viewing window resizes and changes itself very responsively, very instantaneously. But if your connection is bad, the imagery might take a little while to populate. And if you turn your Wi-Fi off, you'll actually notice that even with no new imagery populating, you can still control the viewing window. And that's because that's being handled by your browser by code that's already been downloaded and is running on your computer, whereas the images are coming from a remote server somewhere, a giant ESRI server that can hold detailed imagery of the entire Earth's landmass, and presumably your device can't. So most commercial sites have some mixture of client-side and server-side execution, but it is possible to make a site where all of the functionality is handled by the browser. Basically, your browser downloads some files from the internet, and then everything else happens locally on your machine. And you could just turn your internet connection off at that point, and it would work. This has a few benefits for the developer. The main benefit is you don't have to really maintain a serious web server. For the user, you don't have to rely on your internet connection anymore. So there's no latency once the page is open. It's just running on your machine. There's a long list of reasons why you wouldn't want to do this for most sites and why most commercial sites don't do this. Some I could think of is that if your user has a lower end machine and you want to do something expensive, it will take too long. You want to maybe have your own hardware doing your computation. If you want to store data from your user, like engagement statistics or just form responses, those need to go somewhere, so you probably want a server to collect that. If you want any sort of multiplayer game mechanic or just a comment section, any kind of interactivity between people, there's probably a need for a centralized server. And I guess you could dynamically serve. I'm not going to get into dynamic HTML, but that certainly is easier when you have a remote server. All of those are the reasons why, again, I'm talking about like little demos and math widgets and games and stuff, and not Google Maps or YouTube or any of the big sites, anything like that. The last historical reason why you might not want a completely client-side code behind your site is that you might just not want to write in JavaScript. Like if you're constrained by what the browser can run, and for most of the history of the internet, I'd say that's been pretty much just JavaScript, and certainly not your Python application naturally. The tool that I want to advertise in this talk is Piodide. It's an online tool which changes that for us Python developers. So a little bit of background is that I think I maybe said that most modern browsers can only run JavaScript. It's not quite true. There's another language called WebAssembly which they can also execute. And WebAssembly is not really a human-readable programming language, but it's an assembly language. It's a compilation target for other languages. So if you have a C++ program, say, you could compile it to run, you could compile it to ARM assembly to run on a new MacBook or something. Or you could compile that same C++ program to WebAssembly and run it in Firefox or Chrome. And in the last decade, a lot of browsers have introduced support for this, and so a number of languages have introduced compilers to WebAssembly. And importantly, C has done this. You may know that the reference implementation of Python is in C, so when you're running a Python program on your ARM laptop or something, what's really happening is there's a C program compiled to ARM which interprets that Python for you. And very oversimplified, Piodide provides a similar C program compiled to WebAssembly so that we can now interpret Python in a web browser in addition to in our computer hardware. To do this, to get access to the web browser Python interpreter, you just have to include this link to Piodide's JavaScript in your page header in your HTML, and then you can load Python packages and call this asynchronous function called runPython, which is the simplest way to get basically a Python console where you enter a string and it runs a Python interpreter on that string, which is clumsy but powerful. So in this example here, the 2 variable spelled out is getting the value of the square root of 4. And to emphasize the importance of what's going on, you're setting a JavaScript variable via a computation in Python, which is all you really need to be able to do if you want to make Python code of yours control a static website like the one I showed. This has to be inside a asynchronous code block in JavaScript too, but didn't fit in the slide. Things get a little bit more complicated if you don't want to just run or back here I just call the NumPy routine, but if you want to run code that isn't in an officially distributed Python library, like if you have your own toy widget that you've made, it gets a little bit more complicated. You can't import it quite the same way. You have to include a built wheel for your program into the source for your website so that someone's browser will download it along with the standard HTML and style sheet and JavaScript and all that stuff. And then you can just call this load package command to get, it's a little bit clumsier of syntax than getting NumPy and matplotlib and whatever else is on PyPy. But you can put your own package here. And now that I've done this, later run Python will allow me to import a class in my own that I wrote, basically. So this sets you up to call your own code out of JavaScript. The only thing you need to do to get a site up and running is create event listeners that will be bound to whatever functionality you've implemented that you want to put online. So this is a lot of code, and you don't have to parse the logic, but basically this is the mouse move listener in the drawing window I pulled up at the beginning of the talk. So when a user is holding down the left click and they pull the mouse some direction, it will figure out where that's happening and pass those coordinates into a Python object that I wrote that does some computation, then passes back the pixels that you need to update that JavaScript will use to update the canvas. And so if you're doing this with whatever Python package that's going to be the interior of your site, you'll have some kind of probably multiplicity of event listeners like this that will make calls to your functionality. And this is really all you need. And so this is all I have an example of. I will acknowledge for people that have maybe used Piodide and know what they're doing that there's more you can do than just putting JavaScript literal strings. Not all of your Python code needs to be a JavaScript literal string. There's a lot of good reason why you might want to proxy objects from one language into another. Just to simplify and make things scale a lot better when you're making a lot of calls to Python and when you're doing complicated Python logic inside JavaScript. But this is the minimal example that you need to get a site like this off the ground. And if you have a pretty simple interface with your Python object at the core of it, it's all you really need. So that's the example I have for you. I think I'm probably quite under time, but I want to thank you guys for your attention.
Yeah, we do have time for questions. So if anybody has questions for Frank, please.
Saw your hand first, I suppose.
So this WebAssembly targeted code, is it in NPM or where does it's probably not in Python, or where does it go when you compile it and make it available to Piodide?
So the WebAssembly executable, as I understand it, is the interpreter. So your code is not, at least in the example I showed, like there is no WebAssembly file with my compiled Python code. The Python interpreter, Piodide has already compiled into WebAssembly, and then that interpreter is just running on the Python that I've written. Does that answer your question?
Like NumPy, when it's downloading it, is it in PyPy or is it in NPM, or where do you put the packages that you have?
Using the wheel, right?
So your own packages, you can supply a wheel, or Piodide will be able to pull anything that's in PyPy, I think.
Okay.
So that's how it gets NumPy, and then my drawing widget is just from the wheel that's in the website source. So like in the root directory of the website, maybe.
I see. So it's the native Python code that's being interpreted.
Yeah.
Okay.
Yeah. Back here.
Yeah, don't mean to put you on the spot, but as far as I understand this, aren't we pulling NumPy during runtime, which means the user may have to wait for a while for that to
Yeah.
pull them?
Yeah.
This is bad for UX
It's a
right now.
yeah. It's a little bit. It takes a few seconds before you can draw. That's just
See, that's a quirk of this.
yeah. If you've done something where you have it pre-installed, I'd be curious to hear about how you do that.
Since I'm a Docker pervert, I would probably use Docker.
Okay.
In that same logic, like if you really have it, like that wheel is just like loaded with tons of stuff,
Mhm.
for a very complicated project, that would affect like how long it takes.
Oh, sure. Yeah.
It's cached though, so it'll stay in your browser cache after the first time you've loaded it.
Yeah.
That's cool.
Yeah. It's a simple demo, but that is something you need to be worried about. Like if you want to load like all of scikit-learn or something,
Right.
like it's yeah. Was there? Go ahead. Yeah.
So do you still have to write all the more interactive parts then in JavaScript? A library called, environment called Python, which converts Python directly into JavaScript rather than WebAssembly.
So one thing I didn't show is that you can actually write. You can write most of the interactive code in Python. I didn't do it here because that's actually what JavaScript is designed to do. So like the thing I wanted Python for was like numerics, and the JavaScript is perfectly good for interactivity. But if you don't want to have it in JavaScript, you could have lots more in Python. And you can actually, in Python, import like a JavaScript document that lets you bind event listeners and stuff from a Python script. But I just don't have that here.
Could you run into weird like type friction? And I realize it's a silly question, but at the boundary from Python coming out of Piodide back into JavaScript, how does it
Yeah.
deal with type coercion? Or is it just kind of magically lowest common denominator?
So it knows how to coerce the primitive types, and then it tries to recurse as best as it can. The only conversions that I show are, there's floating point numbers in both, right? And then this is an array, which is I forget if this is a NumPy array or if it's just a list or something, but it's something that can be easily coerced to JavaScript. In general, you get a proxy that will leak memory if you don't delete it, but it does a pretty good job of not causing problems. Yeah. I think I saw this hand first, and then.
Really quickly, just the packages, are there limitations? Or what are the limitations to packages?
Well, as I said.
Thank you, by the way, for the
Oh yeah, thank you. So PyPy you can get. I think there are problems around packages that aren't just pure Python. So NumPy is an exception because that's like something that tons of people use. But in general, if you have like a Python wrapper of whatever C++ library or something, there's more problems that you might have. And then again, like any other pure Python that you have access to, but maybe isn't published online, you need to include the wheel and that wheel will have to be downloaded and installed into the virtual environment.
That's kind of a lot of available language.
It gives you a lot of power, yeah.
Okay. Thanks.
And
Yeah, so I don't see any return, both in that code and in the code on the previous slide. So you're just like implicitly taking the return value of the last.
yeah, yeah, it's I mean, it's kind of like a notebook. Like it will take, if the last statement has a value, it will return that, or it will return like a proxy of that. Yeah. Got everybody?
What do you mean will return a proxy? What does that mean, proxy?
It returns a JavaScript object, basically. Like you can't necessarily, like we were talking about coercion. You can't just take the bytes of whatever is in Python and be like, go ahead, JavaScript. This is, they have their own type conversion logic that. Yeah. Does that make sense?
Yeah. I was trying to make a JavaScript joke and then I decided I should use my words.
I think one question.
Yeah.
So I think what someone asked about the problems with the website freezing due to like loading Python packages.
Mm-hmm.
I was thinking, can you like lazy load the packages, like Python packages, while you render the first website and then lazy load the Python code?
Yeah, you could do that. So again, this is part of why like it's good that all of Piodide, like when you make calls, is asynchronous. So other stuff can be happening at the same time. But ultimately, like yeah, if you were gonna install something huge, like maybe that would take longer than your user wants to wait, and you should figure out a way to just have it ready.
Have you seen successful implementations of this using a web worker so it doesn't slow down the UI thread?
Yeah, you can do web workers.
Okay.
The demo I have is just all one process, but you can one of the actually that's another I forget who asked, but another Python like slew of libraries that don't really, you can't use them, are like multiprocessing and multi-threading libraries, because they basically their line is you should just use web workers and have a different Python runtime in each web worker if you want to parallelize stuff.
Are there libraries that would expose somehow the browser threading to your Python code? Am I making sense? Like the
Maybe
web workers or something like that?
not that I know of.
Okay.
Yeah, you would have to handle the like top level of the parallelism in JavaScript.
I see.
Yeah.
So it's pretty cool, but are there any sizable apps being built with this, or is it really only good for sort of funny demos and things?
Well, I've only used it for funny demos. I don't know what the front ends of like large sites use, but the use case would be when you have something that really needs to be, or you want to be in Python, that you want to run in your client's browser. So probably not super common in commercial applications.
Be nice if they can connect it to the GPU. That'd be nice.
Yeah, I'm not sure that's does anyone know if like WebAssembly can run on GPUs in general?
It just need to construct the code to be pushed to the GPU.
Yeah.
Oh,
Oh, you could, yeah, sure.
APIs through the JavaScript runtime dunks.
I know
Right.
Babylon.js, for example, they can leverage GPU from
Yeah.
the browser.
Okay, so I mean,
There's some
yeah.
way to do it.
You can. It's just a question of how much you have to figure it out yourself. I haven't tried accelerating too much.
Someone needs to make a React for this.
Or a really big fractal, like really.
Yeah.
And none of the numeric libraries are going to support that because they're not written against the way of the GPU.
No.
Yeah.
No. Yeah.
it seems like the real, like, the win here is if you have a whole bunch of logic in like NumPy or Pandas and you don't want to redo it in a JavaScript.
Yeah, that's the win.
That's where the really like win you want.
Yeah.
Right. And also, it's not really like it's for like a kind of a short-lived proof of concept, so that you don't really have to like.
That's the main use case,
That's the space.
and that's certainly that's what I've done, and that's what I intended the talk to illustrate. I don't know that it's better for anything but doing that kind of thing, like demonstrating something that's already written, and you don't want to, particularly like if there's something that JavaScript just isn't good at, like, you know, doing like large matrix linear algebra or numerics like that, like
You can do, but you have to like
yeah,
totally do that in a different way.
Yeah,
If you
yeah.
really want to do. And if you already have it worked out in a notebook.
exactly. Okay.
I have a library called WASM GPU, that's a Rust library that allows you to run WebAssembly on GPUs.
Yeah, that Rust has better WebAssembly support than Python for sure. It also can compile directly to it. Doesn't actually the best like straight up like Mandelbrot zoomers and stuff online, I think, are nowadays they're in Rust with that hardware acceleration. I don't know if they use the tool that you found or not.
Is there like a
But, yeah.
dual Mandelbrot competition?
Not that I know of, but probably there should be.
Now you can do it online.
Yeah.
Sure to win.
Yeah, well,
Everybody, let's thank our speaker.